So now today we're going to set up the telescope and go through some of the procedures for doing some solar observing. And as you can see right here to my right, your left, we have an LX200 Meade 8-inch telescope, which we're going to use for this. We also have a computer monitor with a box to shield it from the sunlight that we're going to use. As you can see here, we have a tripod. We have some of the various equipment that we need to set up the scope, and I see I forgot the power supply, but I'll run and grab that here before we start. But in the meantime here, I'm going to set this up and show you how everything goes together. The first thing we're going to do, we want to make sure that we have a clear sky, and it's not perfect today, but it's reasonably good, so we're going to go with that. I will take the telescope. This telescope weighs approximately 45 pounds, so be careful picking it up. As you can see, the way I'm lifting it is a good way to do it, and you put that down onto the tripod like so, and then we screw the tensioning rod up inside the telescope to secure the telescope to the tripod. And we're going to make sure that it's fairly well centered, which it is. I'm not going to over tighten this too much at the moment. What I'm going to do is show you this. We're going to position the telescope at 90 degrees on the scale here on the left. Put it at 90 degrees like so. And the first thing we're going to do is double check. We want to make sure the telescope is centered. And as you can see, if we rotate all the way in one direction, it hits a stop. It can't go any further than that. And if we go back around the other way, we'll hit a stop in that direction right there. And what we want to do is set the scope midway like so, and line it up with the mark that is over the control panel like that. And this is what we call the home position for the telescope. That's the position that the telescope needs to be in for it to have the proper amount of altitude and azimuth swing capability in all directions. And that would be the way of finding it. The clutches are snug. They don't need to be over tight, but they're snug right there like that. One thing I will mention, there is a finder scope that can be used with this scope, which goes up here on top, but we're not going to use that today because we're doing solar observing, and pointing this at the sun can damage the optics. So we're going to not do that, but I thought I'd show you that anyway, just to provide some basic all-around information about the telescope. Okay, let me familiarize you with a few of the items that we'll be using here. Besides the telescope, the other thing that I ran and grabbed because I had forgotten it earlier is the power supply. Now, any power supply will work as long as it has a 12-volt capability with enough amperage to drive the telescope, which is not very much. I do have a laptop computer which has its own battery, so we don't need to provide power for that. But we do need power for the camera that we're going to be using, and I'll show you that in a minute. But for the moment, I'm going to lay this down here below the telescope. The other thing that we need here, this is a special cable. It's a USB cable that goes with the video camera. I'll go through that in a minute. This is the hand controller for the telescope, and we can plug that in back here into the HBX port. like so. The other thing that we need is a power cable. This happens to be one I have, which doesn't do anything to the power. It just takes 12 volts from the battery up to the port on the back of the control panel here. 12 volt DC in. You plug that in there like that. The other thing that I want to show you here that we need is this. This is the diagonal, eyepiece diagonal, if you will, which is necessary for the telescope to provide an image to an eyepiece or for the camera. And it has a cap, which I dropped, to keep dust out of it here. I'll just set that over here, set it aside. And we will put that on the back of the telescope, and as you can see, there's kind of a dust cap here on the back of the telescope. We'll take that off. The diagonal itself just has a mirror down here at a 45-degree angle. This has threads, internal threads. That has external threads here. And all we need to do is to carefully screw that on like that. Turn it down until it bottoms out like that. Doesn't need to be too tight. Then we can put this back on, and there are two thumb screws on either side that we can use to tighten that down. There's also an adapter for smaller eyepieces, which we're using with the cap just to keep dust out of that. I'll set that aside. Then the other thing I'll show you is this. This happens to be a 32 millimeter 2-inch multi-coated mead eyepiece. It's not a particularly high quality eyepiece, but it's a decent eyepiece, and that will fit right into the diagonal that we have. And there we have the setup for the telescope to function optically. Now, I put this back in the home position. Now, a couple of things that we haven't done yet that I want to show you. One is I have an iPhone here. If I can get it to come alive. I have a compass in here, and I use that to align, and sometimes you have to use the accelerometers in the iPhone to get it to show you the proper direction for north. We're going to lay that right on here, aligning it with the base pad of the fork arm here, and as you can see, we're pointed almost exactly north. It's within 1 degree. Now we're going to tighten this down. So now it can't move. We're perfectly north. And then the other thing I'm going to do, I'm going to show you this. This is a bubble level. I don't know if you can see the bubble, but we're going to set that right on the housing there. And it's important to have the telescope as level as possible, and I can see we need to raise this side of the telescope just slightly. So I'm going to do that. Do that by loosening the screws here, and maybe just That might be just about right. This one here could go down just slightly. The better level we have this, the better performing the telescope is going to have with tracking. And that is, I don't know if you can see it, but that's about as perfectly level as we need it to be. So whatever level you use, make sure you double check that. And then after you've leveled it, I would go back and just re-verify you're still pointed north, and we are. So the compass is no longer needed. So if you have carefully leveled the telescope and situated it in the home position like I've shown, centered mid-stroke in the rotation and at 90 degrees here, and you have it pointed north as we've done and level, it can almost exactly pinpoint objects in the sky even in the daytime. So that's what we're going to hope for, and we'll see what happens here. Actually, one other thing I want to point out before we even attempt to send the telescope to the sun, one of the things that I definitely want to point out is this little device here. This happens to be a homemade one, but this is a solar filter which is designed to completely cover the inlet of the telescope so that you're only getting about 1/1000th of 1% of the light from the sun. And actually I can look directly at the sun with this, and all I see is just a little orange ball in the sky. I'm going to set that aside for the moment. Okay, now what we're going to do is turn the telescope on and see if we can get it to go to the sun. This, as I said, this is a go-to telescope. It's as aligned as well as we can align it in the daytime. If it were at night, we could actually find a couple of bright stars, fixed stars in the sky, and use that to orient the telescope to the night sky. But since this is the daytime, we can't do that. But I think if we're lucky, and we've done a good job with orienting the telescope and setting it up, getting it level and so forth, it'll be able to point almost exactly at the sun even without an alignment. So first thing I'm going to do, I'm going to turn on my power supply here. I'm going to give it 12 volts. I'm going to go ahead and turn the 110 volt inverter on too. We're not going to use that just yet. Now the telescope should have power, and if we turn it on, there's a little red light here which is on. So we have 12 volts, and then I don't know, you may not be able to see this, but here's our display. It takes a few seconds for that to orient itself. Software has to initialize. It says welcome to AutoStar. That's the software program that operates this telescope. You have to be patient for a few seconds. Okay, now it says press 0 to align or mode for menu. Well, we really can't do an alignment because, as I said, there are no stars visible. The only object right now that we can see is the sun. So we're going to use that, and so we're going to hit mode, and then it comes up to align. We'll hit mode again, and I think if we hit mode and hold it for a few seconds, what it will do is it will come out and give you a readout here that says RA dec. That stands for right ascension and declination. Those are the coordinates of objects in the sky. And in order to send the telescope to a coordinate, we need to know what it is. And for that, I'm going to use my iPhone again. I have a program here, and the computer also, I'm going to go ahead and start the computer. Computer also has a software program in it. This one is Sky Safari. This is free, you can download. It's a pretty good program. Let's see, it says sun, and the time is 1:46, which is right. And if we're centered on the sun, it gives the coordinates here of the sun. Right ascension declination is what we're looking for. That's under celestial coordinates. The right ascension is 22 hours 37.5. So I'm going to come around on this side. My cable isn't long enough. So what I need to do is hit go to. It will go to the right ascension number, and it doesn't have the correct numbers auto-filled into it at the moment, so I'm going to overtype it. The sun right now has a right ascension of 22 hours 37.5 minutes. 0.5 minutes would be 30 seconds. So type that in. So 22, 37, 30. And the declination is minus 8 degrees 41 minutes. We have to use the east-west key because the declination has a positive number on it right now. We need it to be negative, so we'll use the west key to send it to the west, to the left, and we'll use the down arrow here to make it be a negative. And then we'll send it back with the east key, and then we'll type 08 41 and 00 minutes, seconds, excuse me. And I think we hit enter. Okay, now the telescope is taking a GPS fix. So this is a nice thing with this particular model telescope. It has its own GPS system, and it's recognized where it's at on the surface of the Earth, and it's downloaded the current time. And as you can see, it seems to be rotating in the correct direction. And I don't know if you can see that, but it looks pretty doggone close to being right on the sun. Now, it may not be perfectly on the sun. What I'm going to show you here is something kind of interesting. I'm going to lower the telescope or the camera down here a little bit and rotate it so that you can see the shadow of the telescope on the ground. And since we can't look through the telescope with the cover on it here, we can't know for sure if it's pointed precisely at the sun or not. It probably is not. But if we loosen the clutch here, we can rotate, and I don't know if you can see that. You see the how the fork is swinging back and forth. What we want to do is get it so it is casting the skinniest shadow possible. Each of these forks need to be as narrow as possible. That says the fork is pointed right at the sun. Now, the telescope itself may not be at the right elevation, and if we loosen the clutch here a little bit, now you can see if I rotate it up and down, you see how the circle of the shadow gets bigger and smaller. We want to make that as small as possible, right about there, like that. And then we can check the fork arm again just to make sure. I would say that's about perfect right there. Do this a couple of times. If we do it very, very carefully, we'll be pointed right at the sun. Now, we're not going to remove this until we put the solar filter and I'll show you how that's done here in a moment. Again, here's the solar filter, and with that it's safe to look at the sun directly with your eye. You can look right at it. It's an orange little ball in the sky. Safe to look at it. It's also going to be safe to look at it through the telescope once we put this on. However, at the moment, okay, we're going to loosen this, and we don't want to expose the telescope to direct sunlight because that will damage the optics. But if we're very careful, we can swap this out and the telescope won't know anything happened. There we go. And that's securely slid on, and with any luck, aha, the sun is right there. Perfect. Yes. Just a hair. Follow this procedure, it will work. There we go. And I see the sun. The sun has some very nice sunspots on it. Right at the moment, some nice sunspots. Oh, very nice. Okay, now that we have the telescope pointed at the sun, it's been a few minutes since I pointed it at the sun and it's tracking perfectly. The telescope, we were careful when we set it up, and got everything calibrated correctly to the sky as close as we could in the daytime. And the telescope is functioning quite well following the sun. So now the next step we want to do is connect up the camera. Now this is a ZWO ASI 2600 mm Pro camera. This is a very, very nice camera. It is a monochrome camera, so you're not going to get color images with this, but it does provide excellent resolution black and white images. And it does have a dust cap on the inlet, and I'm going to make sure there aren't any big dust particles on the sensor. We'll set aside the dust cap, and what I'm going to do is screw this on. This is an adapter for different lens configurations. There's a 16.5 millimeter spacer adapter and a 21 millimeter adapter. We're going to put those two together and screw it on to the camera. And this eyepiece, and make sure we're still centered, we are. I'm going to take the eyepiece out, and you can see there's a thumb screw here. I'll set the eyepiece aside, we'll just put it right there, and we'll put the camera on in place of the eyepiece, like this. Very carefully slide that down in there, like that. And I think the best way is to orient it so that everything is readable right side up and pointed down the center line of the scope like this here. That's pretty much about as good as we can do. Now the camera needs 12 volts, and for that I don't have one, but if I had a connector that would have two outlets, we could power it from the same one that's powering the telescope. But in this case we have this power supply here, which is a 110 volt to 12 volt converter. We'll put that, plug that in down here. And we got 110 volts there. And check this, there should be a little green light, which there is. That's good. And we will plug this in to the camera. Right here, there's a 12 volt in, right there. Now the camera has power, And then the other thing we're going to do, we're going to plug in the USB right here like that. It says USB 3.0 in. We'll plug that in there. And everything should be functioning. I hear a fan running, so I think the camera's working. Now the next thing to do, and maybe what I'll do is bring the camera a little bit closer. Okay, now I've brought the camera a little bit closer, and perhaps you can see the laptop. Perhaps not. It is difficult. Sometimes it might be good to have a cloth over your head to completely cover yourself from any stray light. Right here we have a lot of reflective light from the ground, which is not good. But I can probably increase the brightness of the display so you can see it better. So I've made the display as bright as I can. Now I'm going to come over here and open ASI Studio, and we have a number of selections. We're just going to take the top one called ASI Cap, planetary imaging, and it's going to come up here. Now what it wants to do, it wants to select a camera. So over here it says ZWO ASI 2600mm Pro, which is the camera. We're going to connect by hitting the right arrow. And as you may be able to see, there is an image here. It's a little bit dark. We'll see if we can brighten that up a little bit. We can increase, we have controls here, we can increase the gain, and it takes a few seconds for that to take effect, but you should be able to see now an image building on the screen. We can change the exposure. Yeah, there we go. Now you might be able to see it. There's the exposure, and you can see the sunspot that we have there is very, very large right here. There's a very, very large sunspot right there. And what we can do here, we can change the resolution of our image and enlarge the sunspot. Now, the problem here is we can't see the sunspot because it wasn't centered. Let me center it. Let me go back here. I'm going to go back to the image we had before. Okay, and what I'm going to do, oops, that was not good, that was too much. Unfortunately, we lost the sun there. Okay, one thing I forgot to point out, when this telescope, the first time you try to use it using the electronic hand controller, you need to give it a speed. So what I've done is I've changed the speed number to a 5, and that slows it down to the point where, if you can see my screen here, you can see the sunspot is moving towards the center of the picture. And that's pretty close to the center right there. And I'm not sure which way you want to go. Up, we want to go the other way. I'm going to lower it down. Hopefully you can see this. Now the sunspot should be pretty close to the center of the screen. Now we can change the magnification factor. And I like changing the magnification too because it gives you a little faster frame rate when you do that. So there, now you can see the sunspot is pretty large, and I think what I'll do is decrease the exposure a little bit. You can see it better. Maybe decrease the gain a little bit. The other thing we can do is come down here. There's some display items here. We can increase the contrast. That makes the sunspot a lot more visible on the screen. Maybe take that up to about a 5, close to it. And display brightness, maybe we can decrease it just a hair. So hopefully you can see that. Now what I can do here is try to focus it. That might bring it into sharper clarity. That might make it worse. That's made it worse. And that's making it worse. So we were pretty close to it being on focus originally. That's about as good as we can do. So now let's go back. There. That's pretty good right there. And we can take a picture of that. We'll go back to full screen. Right there. And maybe what I'll do is move it the other way. Move it over. Like that. Scan around a little bit, see if there's any other sunspots. And as you can see, there are some smaller ones over here on this side. And now what we can do is take a picture of that. We can capture, and what I'm going to do is I'm just going to capture one frame. You can select the number of frames you want to capture, but we'll just go with one. And that will save that on the computer for download later. But in essence, now you've seen how the system works. There are some very excellent sunspots out there, and this is absolutely safe. Even if the solar filter came off of the telescope, the worst that would happen is we would damage the telescope, but since we're looking at a computer screen here, no eye injury can result from that. So it's absolutely safe. Looking through the telescope by eye always has inherent risk. If you know what you're doing, it's safe. I know what I'm doing, and the people operating the scope will know what they're doing. But for folks at the school observing the sun during the daytime like we're doing here, this is the safest, best way to do it. With the laptop computer, we can hook up screens and do other things with the images. We can save them, we can email them for later. Let's go take a look and see if our picture downloaded properly. Okay. It's going to depend how you're set up with your architecture. For me, the image should have come in under a date of 2024. Today's the 26th. So that's the only one we've got right there. There's our picture. Let's see what it looks like. Ah, that looks pretty good. Looks pretty good. So there you have it.